Hello everyone, here is estimating a population mean. Okay, and as part the point estimate of population mean is sample mean showing with X bar. Okay, on this example I want to find the sample mean or point estimate So a point estimate is X bar, and how we can find that? Here on this table we have all these data. So the website allows drivers to report the miles per gallon of their vehicle. The data in the table show the reported miles per gallon of 2007. Obtain a point estimate of population mean. Okay, here we have all these data and I want to find point estimate for this example. What that means, how we can find mean. As always, we should add all these numbers and then divide by how many numbers we have here in this table. We have 13. So denominator is 13 and adding all these numbers on top, 28.5 plus 23.8, 25.2 plus, so I'm adding all these. So adding all these, now here I have 26.1, 24 divided by 13. So adding all these, divide by 13, rounding it, the answer is 24.131. So this one is point estimate of population mean. Here we have students t distribution. So the confidence interval for the population mean is of the form of, so we have this form is point estimate minus plus margin of error. So I'm writing that. So what that means is our mean is between point estimate plus, so this is the plus we have here, plus margin of error, and then this side we have minus E. So point estimate is X bar, and here is E. So here we have X bar plus minus E on these two sides. So this is confidence interval. Or confidence level. So it's same thing. I may use CL, so there is no difference between these two. Okay, now what's the difference between T distribution and Z? So when we're gonna use T or when we need to use Z scores, is that the T distribution have standard deviation higher than 1. Remember for Z distribution, because that Z is normal distribution, we had standard deviation equal to 1. But when standard deviation is higher than, if that was higher than 1, and is dependent on the sample size, then that means that we're going to use this distribution. Okay, so it's dependent on sample size. Okay, now next part, as the sample size increases, so when sample size increases, t-distribution gets closer to 0, standard normal distribution. I remember for a standard normal distribution, we had that z was equal to x minus mean divided by standard deviation, and mean was 0, and standard deviation was equal to 1. So when the sample size increasing, the distribution gets closer to normal, a standard normal distribution. And t-distribution are centered at 0. Remember for z also we had, but we had in between was 0. And there is a different t-distribution for each sample size. Because again, this is dependent on sample size, that's why I have this part. So based on what sample size we have, we're gonna have different t-distributions. Okay, next page. Here is what we have for students' t-distribution. Here again, so this is sample mean. This S is sample standard deviation. And N is sample size. Okay, what we have here, when this N increases, so when we have this one, that means that S, or sample standard deviation, gets closer to population standard deviation. So this S was sample standard deviation, and this one was population standard deviation. So population standard deviation. Okay, then here on this part we have degrees of freedom. How we can find degrees of freedom, and what that is the number of sample values that can vary after certain restrictions have been imposed on all of the data values. Okay, how we can find that degree of freedom is equal to sample size minus 1. So whatever is your sample size, you need to subtract 1 to find degrees of freedom. So this is important, this part, because we're going to use that one to find t-distributions. Okay, now on this part we had the t-distribution. This is very similar to what we have for standard normal distribution. It's like having using a empirical rule in that one, but it is difference because here the t-distribution is different for different degrees of freedom. So depending on what sample size you have, and also what that means, depending on what is your degrees of freedom, because this degrees of freedom is based on what the sample size is. Okay, then this is centered at 0. See, the center is 0, exactly like we had on z-scores normal distribution. So that means this is symmetric above the 0. So then third one, the area under the curve is 1. So we had this one before, area is 1. And what that means, the area under the curve to the right of 0 equals the area to the left. So what that means here the area from this part to this part, so area to the left is 0.5. So this is 100%, this is 50%. And what we have on the right, exactly same thing as 0.5 or 50%. So this is equal to 1 divided by 2 or 0.5. Then number 4, as t increases or decreases without 1 and the graph approaches but never equals 0. See, here these are close to this line, but it's like this. So remember how I was drawing this normal distribution is exactly the same thing here. We have something like this. It's getting closer to this line, but it's not equal to 0. So we have something here in between, so it's not 0. Okay, so never equals 0. Okay, then I'll explain what we have here in number 5 and 6 based on this t distribution. So this yellow one is a t distribution when our sample size is equal to 5. When we increase the sample size, so to, for example, 15, so that is the red one here. See what's the difference? This getting closer to normal distribution when I increase the sample size. And what we have here is, first I had this yellow one was for sample size 5, but now I have this red one. Again, it's getting closer to what I have for normal distribution. So for when sample size is 5, we have more area in tells. So more area in tells when n is 5. But after that, after increasing to 15, the sample size is equal to 15, now the area to the area in here on this part in tells, it's less than what we had on this part. So it's less. So that part is decreasing. Okay, and the last one, so this is normal distribution. We had this part before. Okay, so just the point is that when you increase the sample size, there's distribution getting closer to normal distribution. Okay, now next page. Now this part we want to determine t values. Okay, recall that when we use z alpha, when we have this z alpha, that z-score, whose area under the normal curve to the right of z alpha is alpha. So I'm writing that. So this z alpha. So this alpha is the area to the right. So right area. And we have the same thing for t alpha. So this alpha here is, again, area. Okay, for example, find t-value, and okay, I want to add note here on this part. Alpha is always area to the right. Okay, now example 2. Find the t-value such that the area under the t-distribution to the right of the t-value is 10% and degree of freedom is 15. So finding t. So here we have 15. Okay, example number 2, find the t-value such that the area under the t-distribution to the right of t-value is 10%. So I have 15 is degree of freedom and area is 0.10. So that is equal to, using calculator, we should use inverse t. So on this part, I should use left tail, comma, degree of freedom. So what that means here on this part, inverse t, here area is 0.10 instead. We should use, because this is area to the right, what we have to the left. Here area is 0.90 or 90%. And degree of freedom is 15. Okay, so let's use this one, use a calculator. So you need to press second. So using TI 84, we have second, then wars, then choosing number 4, inverse t, and then enter data. So we have area, degree of freedom. Okay, so for a second, then scroll down, inverse t, enter. Now area is 0.90. Okay, let me take picture of these steps. I already entered 15. So area here in this part we have 0.90, degree of freedom is 15. So after you enter these two, area and degree of freedom, then enter, again enter, and enter. So the answer is 1.34. Okay, if we wanted to run this, the answer will be 1.341. Okay, so we rounded this, and the answer is 1.341. And also using the table here is what we have here is area in right tail, and we had 10%. Since this one is in right tail, that's why we are able to use this one, and degree of freedom is 15. So the answer is 1.341. But it's better to learn how to use calculator. When you're using calculator, you need to enter area to the left. So this is area to the left. And if it's asking you to find the area to the right, you need to work based on what you have on left. Okay, then part B, find t-value such that the area in right tail. So here again we have right tail is 5% with degree of freedom is equal to 30. So what I have here is this t distribution. Here we're asking for right tail, so this is what we have on right. And area is 5%. Okay, now find the answer. T-value exactly same as the previous one. Now here degree of freedom is 30 and alpha is 5%. So I want to use calculator. So use TI-84. So using inverse t distribution, and here this is area to the right, it's 5%, but that means I need to use area to the left, which is 95%. So 1 minus 5% is equal to 95%, and degree of freedom is 30. So again, let's use calculator to solve. Press second, wars, choosing so this is what we have. So second wars, then choosing number 4, then enter for area. Now we have 95, and degree of freedom is 30. Okay, this is what I have. Then enter. Okay, so here is the answer is 1.697. So rounding that, the answer is 1.1697, so 697. So 1.697 is the answer for this part. So that is our t-value. Now part C, find t-value such that the area left of t-value is 1% with 18 degrees of freedom. Okay, you may have different methods for this one, but if you want to use table, let's use that one. So where's our table? So we have T table is this one. And T value is 1%. Okay, we have this board. See, what I have on top is T.99. So what that means, instead of this 1%, I'm using that 0.99. Okay, and degree of freedom on this port is 18. Okay, so the answer is 2.552. But after using calculate, I'll show you that the answer is not positive. The answer should be negative actually, because we work based on this is the area to the left, and we work based on T 99%. So the answer for 0.99% is positive, and the answer for 1% is negative. So that may be a bit confusing using table, so I'm going to use calculator instead. I'll explain that one here. So I'll use table. We have T, degree of freedom is 18, and we have 0.99 because this is area to the right, as I said. And then the answer for that port is 2.552. Then T18, 1% is equal to negative 2.552. Okay, this is area to the right, and area to the left, you only need to multiply by negative. Or using calculator, so 84. I have inverse T. So our alpha is 1%, and this is area to the left. Remember, here on this part, when using TI, you need to have area to the left. We already have that one here. So that is left. And degree of freedom is 18. Okay, so I'm using calculator. So second was choosing number 4, inverse T. Then for area inter 1%, and degree of freedom is 18. Okay, so we have these. Then enter. See, what I have is the final answer is negative 2.552. So using calculator here on this part is easier. You don't need to use table for this part. So let's go back. So I rounded that, and the answer is negative 2.552. Okay, if I want to explain this more than this part, but remember on test you only need to use this because this is easier. So let me explain this one more. What we have here is that when t, you have degree of freedom 18, and this is to the left. What we had for t value was that here alpha is area to the right. So what that means, here I should have 0.99, and we don't have this one in chart. So and how I got this 0.99 is 1 minus is 1%. So 1 minus 1% is equal to 99%. So instead of that, use 18, 1%. So remember, on this part I should use right area, but this is left. So, but on calculator here we have left. Okay, so this is left on calculator, but this is right. But this should be right, but this one I used left. What that means, this is based on what we had on table that I showed you, we got positive 2.552. So the answer based on what we have here on this part, the final answer is equal to negative 2.552. Exactly what I did here on this board. So I only wanted to explain more get that since we don't have this one in chart, that's why instead of using this one, I use this and then multiply by negative. Okay, we finished this part. Okay, next part, construct an interpret confidence interval for a population mean. Okay, so this is population mean, sample standard deviation, sample mean, number of sample values, margin of error, and this is critical value. Exactly same as z. Remember we had z alpha divided by 2. That was critical value, and this is for t. So this is critical value for t. And the requirements for, so this is requirements for construct the confidence interval. So confidence interval. What we have here is that the first one, we had this part for normal distribution, remember? And the previous section also we had all these. So number one, we should have random sample. Number two, there's sample size. This should be less than or equal to 5% of population size. This way, we can say that this is independent. Then number three, population is normally distributed, or in other words, our sample size is greater than 30. So population is distributed. So it's normally distributed, or in other words, we have the sample size greater than 30. We had this one before. Okay. So I already had this one in the first page. So mean is, this is our interval, mean is between this x bar plus error, and on this side we have x bar minus error. Okay, I want to add something here. So to find points estimate, so points estimate, so that is x bar. This is equal to upper confidence limit. So adding this one, so plus lower confidence limit. Then divide by 2, because here we have upper, lower. Adding these two, divide by 2 to find point estimate. Then margin of error. E is equal to we have exactly the same thing. The only difference here on top we had plus. Now in this part, we need to find the difference between upper and lower. So upper confidence limit. So I'm showing with CL minus lower confidence limit. Then divide by 2. Now example number 3. So this was confidence level limit we have CL. Now example number 3, a simple random sample of size n and the sample mean x bar, and that is 18.4, and sample standard deviation s is 4.5. Number A, so part A, construct a 95% confidence interval for mean if the sample size is 35. So here on the first bar, sample size was not given. Now, and for each part, we have these information. So this is sample size is 35. And then part P, sample size is 50. Okay. And what we have for X part is 18.4. And sample standard deviation is 4.5. So on this part, I want to find margin of error using this E equal to t value times sample standard deviation divided by square root of sample size. So we're going to use this one here on this part. So what I have here is for 95% confidence. So alpha divided by 2 is equal to, so how we can find alpha? Let me write that part first. So alpha is equal to 1 minus 95%, which is this one. So 95% is equal to 5%. So this is alpha. Using that one here, so we have 5% divided by 2, and it's equal to 0.025. Okay, and also we have this n is 35. So based on that, finding degree of freedom. In the previous examples, I didn't use this sample size. We directly use this degree of freedom. Degree of freedom is n minus 1. So 35 minus 1, degree of freedom is equal to 34. Okay, now finding t value. So t, now we have degree of freedom, and I'm using alpha divided by 2. So degree of freedom is 34, and alpha divided by 2 is 0.025. Okay, here again, I'm using calculator, using inverse t distribution. As I said, this is what we have on right, so always is like that. Here, didn't mention that this is to the left, so this is to the right. Now, on calculator, you need to enter what you have on left. So on left, we have 1 minus 0.025, so this is 0.975, comma, degree of freedom is 34. Okay, let's enter these. So first, second, worst, choosing number 4. Area is 0.975. Degree of freedom is 34. So we have these. Then enter. Okay, the answer is 2.0322. Okay, I'm rounding to 3 decimal, so it's 0.032. Okay, so the answer for T here we got 2.032. Now using that one, we can find E. So E is equal to T times s divided by square root of n. So that is for t here, and that's why we got 2.032. Then multiply by s is 4.5. And n is 35. That is equal to 1.546. Okay, after that, I want to find this confidence interval, this one. So confidence interval. So mean is between x bar minus e, x bar plus e. So for x bar, we have 18.4 minus e is 1.546. This side we need to add. We have same numbers. So what we have here, our interval is, so here is subtracting, here adding, we have 16.85, comma, on this side is 19.95. Okay, so this was the final answer because it's asking to construct a confidence interval. So this is the final answer for this part. Then part B, again, construct a 95% confidence interval for mean if the sample size, now here's sample size, instead of 35 is 50. And it's asking how does increasing the sample size affect the margin of error E. So same thing. So we're gonna have all these steps here on part B again. Since I have 95%, again I have this part. So 95% confidence, alpha is equal to 5%, and alpha divided by 2 is 0.025. So same thing on this part, alpha divided by 2 is 5%, divided by 2, it's 0.025. And n sample size is 50. So based on that, degree of freedom is n minus 1. So 50 minus 1 is 49. So here we have 49 for degree of freedom. Now finding t. So t here is degree of freedom. We have 49. Then here alpha divided by 2 is 0.025. So here again use calculator. It's inverse t. We have exactly the same thing, 0.975. Now instead of the 34, we have 49. Okay, let's use calculator. So second words, number 4. Now change that in degree of freedom from 34 to 49. Okay, so we have this, then enter. Okay, what we have here is 2.0095. Okay, rounding that, the answer is 2.010. So the answer for this part is 2.010. Then next step, finding E. Okay, so S is 4.5 divided by square root of n. So that is 1.28. Okay, so 4.5 divided by square root of n. Answer is 1.28. Now finding confidence interval. Mean is between x bar plus e, x bar minus e. And x bar is 18.4. So this was given on this part is 18.4. Minus error is 1.28. And here on the side, same numbers, now adding. So confidence interval, what we have here is, this is lower bound, and here is upper. So our interval is 17.12 on this side, comma, on the side adding, we have 19.68. So this is our final answer. Okay, then it's asking how does increasing the sample size affect the margin of error? When you're increasing the sample size, there's error decreasing. So increasing sample size decreases margin of error, E. Now part C we have same thing, but the only difference, previous part we have 95% confidence interval, here is 99%. And again sample size is 35. So our steps are exactly same. So for 99% confidence. Alpha divided by 2 is equal to, so alpha is 1 minus, here is 99%, so 1 minus 99% is equal to 1%. That means using that 1% here, divide by 2, this part is equal to 0.005, n is 35, and degree of freedom, which is n minus 1, is equal to 34. Okay, the next step, finding t. So degree of freedom is 34. Alpha divided by 2 is 0.005. So here again, using calculator, inverse t distribution. So this is area to right, and instead use area to left. So 1 minus 0.005 is 0.995, and degree of freedom is 34. So enter these two using calculator. Second was, then enter area is 0.995 and degree of freedom is 34. Then enter. The answer is 2.728. So I'm rounding that to 3 decimal places. So 2.728. So what that means, the answer for this part is exactly the same. So the answer is 2.728. Now finding margin of error. That is equal to t times. So t is 2.728 times s is 4.5 divided by square root of n is 35. So this is equal to 2.08. Now next step, finding confidence interval. So for confidence interval, we have mean between x bar minus e, x bar plus e. Okay, then now I'm finding what we have on this board. Left side is lower bound. So finding lower bound. So I'm writing different method. So it's exactly the same, but remember on this part, on the previous one, I said that this is lower bound and this is upper bound. So for lower bound, I'm using x bar minus e, and for upper bound, I'm using x bar plus e. So lower bound is equal to x bar minus e, and upper x bar plus e. Okay, so x bar is 18.4 and e is 2.08. So that is equal to 16.32. And for this one, now here we have same numbers and adding them. So it's 20.48. That means our interval is 16.32, 20.48. So this is the final answer. And here again, it's asking how does increasing the level of confidence affect the margin of error. Okay, increasing the level of confidence increases the margin of error. Okay, let's compare that one with this one here. See, here confidence interval is 95%. Part C we have 99%. Margin of error is 1.546. But here on part C we have 2.08 for margin of error. So this is increasing. So increasing the level of confidence. The level of confidence increases margin of error. Okay, now part D, if the sample size is 15, confusions must be satisfied to compute the confidence interval. Remember from the first page to have this one normally distributed, I should have the sample size greater than 30, but this one is less than 30. So based on that, with a sample less than 30, so n less than 30, the original population must be normally distributed. So say I had this one here on first page. What we have, the requirements number 3, population is normally distributed when sample size is greater than 30. Since we don't have that one, the original population must be normally distributed. Okay, now number 4, how much time do Americans spend eating or drinking? Suppose for a random sample of 1001. So n is 1001. Mean amount of time spent during eating or drinking per day is 1.22. And standard deviation is 0.65. Part A, a histogram of time spent eating and drinking each day is skewed right. Use this result to explain why a large sample size is needed. To construct a confidence interval for mean time spent eating and drinking. So why we should have large sample size? The sample must be large and should be more than 30 so that the distribution of the sample mean X bar will be approximately normal. So again, I'm using what the requirements was based on number 3. So we should have n greater than 30 to have normally distributed. So the sample must be large. what that means, more than 30, so that the distribution of the sample mean X bar, this one, will be approximately normal. Then Part B in 2010, there were over 200 million Americans aged 15 or older. Explain why this, along with the fact that the data were obtained using a random sample, satisfies the requirement for constructing a confidence interval. Okay, so back to this part. So we need to have all these. So we already have random sample, and we should have the sample size less than or equal to 5% of population size, and this n greater than 30. So we should have n greater than 30, and based on step 2, what that means that we have independence. Okay, back to here. Okay, so all 3 requirements, we should have all these. So we have all the requirements because number 1, we have simple random sample. Number 2, our sample size should be less than or equal to 5% of population. That means that we have independent. That is because sample size is small compared to the population. So, and we have this one too, and less than or equal to 5% of population size. Since sample size is small, what was sample size? Sample size was 1001, and here population is 200 million. So it's small compared to population. Okay, then number 3, n, which is our sample size as 1001 is greater than 30. Okay, so remember that n is, for all of these, n is 1001, and this population size, so this is sample size, population size is 200 million. Okay, now part C, determine and interpret the 95% confidence interval for the mean amount of time Americans age 15 or older spend eating. drinking each day. Okay, so confidence is on 95%. So for we have so alpha is 1 minus 0.95, that is 5%. Now using this 5%, alpha divided by 2, alpha as 5% divided by 2 is 0.025. Then our sample size is 1001. What that means, degree of freedom is n minus 1. So it's 1000. Now finding t, we have degree of freedom is 1000. Then alpha divided by 2 is 0.025. Okay, so here again using calculator. So this is what we have on right. Now writing using what you have on left is point, so 1 minus 0.025. Now we have 0.975 and degree of freedom is 1000. Running it, the answer is 1.962. So exactly same steps. Press second verse, choosing number 4 inverse t, and then enter area 0.975 and degree of freedom is 1000. Then enter the answer is this one. Then after that, finding E, margin of error, is equal to t times 1.962 times s divided by square root of n. Okay. S is 0.65. Okay, from this part, S is 0.65 and N is 1001. Okay, that is equal to 0.040. Okay, now finding confidence interval. So X bar plus E, X bar minus E. What you have on left is lower limit, lower bound, and what you have on right is upper bound. So X bar is 1.22. So that was given. X bar is 1.22. Minus E is 0.040. And this side adding 1.22 plus 0.040. So the answer is 1.180, 1.260. Okay, so this is the final answer. Our interval is 1.180, comma 1.260. Okay, and asking to, okay, we should interpret this one, what that means. So we are 95% confident that the mean amount of time spent is between these two numbers. So it's between 1.180 and 1.260. Okay, now part D. Could the interval be used to estimate the mean amount of time 9-year-old Americans spend eating and drinking each day? Explain. Okay, can we use this interval to estimate? The answer is no. Why? Because only Americans 15 or older were sampled. So here we don't have 15, this is 9-year-old, and we only had 15 or older. Okay, so the answer for that was no, because we had 15 or older, but this one's asking for 9-year-old. Okay, next page. Now, this part we need to find sample size to estimate population mean within a given margin of error. Okay, so this n is equal to z times sample standard deviation divided by margin of error. And this part we're not using t. The reason is since we need to know degrees of freedom. So that is okay. We cannot use t since we need to know the degrees of freedom, which is based on the sample size. Okay, example number 5. Okay, the doctor wants to estimate the mean. That is for all 20 to 29-year-old females. How many subjects are needed to estimate the mean? For all 20 to 29-year-old females. Within 2 points, with 99% confidence, and as sample standard deviation is 13.4. Okay, then suppose that this doctor would be, so we'd use this one, so we have 95% confidence. Then how does the decreasing confidence affect the sample size required? So first we're going to use 99% and then we have 95%. So we have 2 parts. And we need to find what the sample size is. How this confidence will affect the sample size. So we have 2 parts, part A. So that is within 2 points. What that means, remember for mean I had, this was x bar minus e, x bar plus e. So this is within margin of error, and since that one is within 2 points, that means that e, or margin of error, is equal to 2. So e is 2. And on this part I have 99% confidence. Okay, so based on what I have here, alpha is equal to 1 minus 99%, that is 1%. So alpha divided by 2 is 1% divided by 2 is 0.005. And S is 13.4. Now finding Z. So alpha divided by 2 is 0.005. Using calculator here, press second, worse than, choosing number 3, inverse norm. This is exactly like t distribution. This is what you have on right. So instead, use what you have on left. So this is right. So area to the right, there's 0.005. On this part, use what you have on left. So 1 minus 0.005, we have 0.995, comma, mean as 0, standard deviation 1. Okay, let's use calculator. Second, worse. Number 3. Okay, so choosing number 3, enter. The area is 0.995. So what I have is this one. Mean 0 and standard deviation 1. Then enter. The answer is 2.500. Okay, here is what I have. It's 2.575. Running at is 2.576. Okay, so the Z is equal to, okay, now finding sample size. Okay, using what we have here on this part, and is equal to Z times sample standard deviation divided by error, then squaring that. Okay, so we have 2.576 times standard deviation for sample is 13.4 divided by E is 2. Okay, rounding it, we have 297.9. That means we need to have 298 patients. Okay, so for this part, sample size is 298. So that was part A. Now part B, instead of using 99%, now we have 95%. Okay, so part B, here again, so error is 2. Now we have 95% confidence. So alpha is 1 minus 95%. That's 5%. Then divided by 2. So here is 0.025. So the same thing as is 13.4. Now finding Z. So Z, here we have okay, again using TI-84, the inverse norm. So this is what you have on right. Instead, using what we have on left, we have 0.975. Then mean is 0. Standard deviation is equal to 1. So see, we have exactly the same thing. The only difference here, area is different because our confidence is in different and we got different alpha. Okay, running that, the answer is 1.96. So this is 1.96. Okay, after you got Z, we can find sample size. So exactly what we did here on part A. So N is equal to, on top we have Z times, so Z is 1.96. So I'll multiply this one. S is 13.4. E is 2. Rounding, the answer is 172.4. What that means, we need 173 patients because I'm not able to use 172. That's why I'm rounding this up. So we need 173. Okay, now compare these two. What we have here, the difference is that on the first part we had 99% confidence and sample size was 298. And when decreasing this confidence to 95%, the sample size is also decreasing. So decreasing confidence level decreases sample size needed. So decreasing confidence level. decreases sample size. Okay, we finished this part. Hope you enjoyed this one. Bye bye.